Okay. Okay, good morning, everybody. So we would like to go to the chapter 1, and all the slides are the E-class. Do you know E-class?
Yeah.
Okay, perfect. So today we will talk about the ionizing radiation, and I think all of you have review of the basic of ionizing radiation. So today we will go deeply in radiation dosimetry. Okay, so in this chapter, only three sections. One is for introduction, and the second one is type and the sources of the ionizing radiation, and the third is how to describe the radiation field. So we would like to focus on the radiation field. The Chinese is 场, 辐射场. Okay, so how to describe the radiation field is very important. So can you figure out some of the definition to describe the radiation field? Please discuss with your classmates near around you. Tell me what is the radiation field. You can think about it right now. 1 minute, okay? 请你跟你的左右同学讨论一下什么叫辐射场，可以用什么东西叙述它？ Maybe next time all of your three should sit together because you use the same language. Yeah. Okay, so how to describe radiation field? What come to your mind?
Because, for example, this is the electron, and when the ionizing radiation points towards it, that's the radiation. It's basically the area, the surface area where the ionizing
Yeah, I guess I know.
Where the space
you are from the macroscope, so every after and also the cycle. But for the microscope, because because in inside the trials when diagnose the thought process the so in that and for certain issues and when
Okay, time is up. Right now I stand here, so can you give me give us your answer? What is the radiation field? What is the definition? How to describe it? You can use Chinese, I just translate it to English. OK， 好，那辐射源用什么叙述它？哦，好，可以发现有一部分讲出种类，可是你怎么去叙述它的数量？量？哎，你们这一组只有它吗？哎，我听到非科学，那是放射性辐射。OK， 还有吗？能量、活度还有 Okay, so when we talk about radiation field, it is related to radiation, right? Okay, so all of you talk about it. And that group give us an example that is an isotope, right? You give us an isotope. So for the isotope, we will talk about its activity. So we using some of you give me the background to describe it. This is the how is its number, right? So we talk about radiation field. We talk about the radiation type, and we need to talk about what is the amount of it. Okay, so you talk about background. So that means it's a disintegration, right? It's a second. Its definition is one disintegration per second cause one background. So that is a number, right? So we talk about the number, and this number can across a field, across an area. So we cross an area. What is this? It's fluence. And all of you also talk about the energy. So when we times fluence and the energy, it is energy fluence. And all of it can related to time. So per second. So we will say it is fluence rate and the energy fluence rate. Okay? And this radiation interact with your material. Then that is deposit its energy. So maybe sometimes we will talk about dose, right? And our dose rate. Okay, all of this can describe a radiation field. I give you a quick idea of it. OK， 了解吗？要用中文讲一遍吗？不需要，对不对？可以哈，好 ，OK， 好。So go back to our topic, ionizing radiation. So we move to another. This one I think it's easy. So for all, okay, for ionizing radiation, why we need to talk about it? Because it applied in different field. This is an expertise field, like a medical application or nuclear power application. So we needed to talk about it. And when we would like to talk about radiation dosimetry, we must familiar with the radiological physics. That is how the ionizing radiation interacts with material. So I give you one slide that you can familiar with this one. Based on the radiation interaction with the matter, and they have a special phenomenon for each one of interaction. So you must familiar with it. And based on this interaction, it's related to the energy transfer. Energy transfer, and then for the medium, gets the energy absorption. Okay, so it is a step. First of all, I need to have the radiation interact with the medium. And then, because the interaction, energy transfer to the medium. And then the medium get absorbed those. Okay, so that is the sequence. So I hope you familiar with it. And for the radiation dosimetry, we talk about the energy deposit in the medium. It seems easy, right? But it's not that easy because we have a lot of constraints. You need to think about it. I give you an example. If you have a detector this big, and you have another DNA, okay, DNA, it's around angstrom or nanometer. Okay, this is millimeter. Okay, the size is different, although it's similar. It's okay, it's centimeter, I think. Okay, centimeter. The dimension is centimeter. The DNA dimension is around angstrom. Okay, so it's about a few nanoseconds or smaller than that. Okay, so the radiation interaction with this one, this ionization chamber and the DNA, the deposit energy is the same. Actually, no. So in this slide, we will talk about some phenomena. So I hope you have some idea of this. And then we move to, so we will focus on the dosimetry. It's the main target of our classes. So you must be familiar with these ideas. And then we move to the history of the radiological physics. All of you know, right? Röntgen is a German. He found X-ray. So he didn't know what light of that is. So it called it X because we don't know that is what is that. So it's over 100 years. Over 100 years, right? At this time, 100 years I am in the school. So that there are a lot of acceleration for this 100-year celebration. Okay, so X-ray help us a lot. And then becquerel actually is the unit. Becquerel found radioactivity. So we use its name as a unit of a radiation. Röntgen also the name of the radiation unit. So what is the unit of Röntgen? What does the unit mean? Do you know that? 就是 Röntgen 是什么东西的单位 ？Exposure? Exposure? Is that right? Yes. Okay. So for this word, it can be a noun, also can be a verb. Okay, but in Chinese, please write down like this one. 要放日字旁 okay? And so the Becquerel found the radioactivity, and Marie Curie, it found get the radium. Okay, so Curie is also the unit of radioactivity. So what does 1 Curie mean? Pardon?
Isn't 3.7 megabecquerel?
It's a relationship from the Becquerel and the Curie. It's a relationship. But what is the definition of 1 Curie? 就是1 Curie 的定义是什么 ？Do you know that? 1 gram of radium-226. Okay, so this is the definition of 1 Curie. All right, Roswell. Roswell have a famous experiments that found the alpha and the beta from the nucleus. And Villard found the gamma ray, and Einstein found the energy and mass can transfer to each other. Okay, so mass could be energy, and energy could be mass. Could you give me an example for that? From the radiological physics you already know. Could you give me an example? Energy and mass transfer. 看起来很像，可以告诉我一个吗？
再想一下。
你在想 ？OK， 有人脑子里面有答案吗？什么？成对产生。OK， so pair production. How? 怎么样？如何产生？ 所以是什么呢？ Okay, so energy. This is the energy become mass, right? Right? And the mass is electron and the positron, right? Okay. Other example? Maybe annihilation. 互毁, right? Annihilation. If you have a positron and it lost all of its energy, it will annihilate with an electron, and it become a 2 gamma ray, right? Okay, so these all of the important concept from this historical process. We found all of it, so we just get quickly and to know of it. And first of all, we would like to talk about the type and the source of ionizing radiation. So here I will move to next slide. Here. So what is the ionizing radiation? What is the definition of ionizing radiation? It is related to excited and ionized. So what is ionized? What is ionizing? According to your definition, can you draw a picture to tell me what is ionizing? Did you get it?
Yeah, I will need to leave today also. Earlier. Yeah. It's in my foot and I got an infection probably.
So please draw a picture. Okay. So
This is and then when we get the answer an electron in the nucleus, it will, if there is enough energy above the KE, then it will give the electron.
yes. What is what kind of ejection is?
Well, just
If you just based on your picture, what is the ejection? Total injectors.
Yeah.
What is that? Okay. What is it? Oh, it's nucleus and it's mobility backbone. Okay, so can you give me an example?
Maybe plasma.
Well, that is heat, right? Give me in because excited state. I'm not going to make that because under vivid conditions when we need so alright, so what is excitation? If we have a nuclear here and we have orbit the orbit, electron orbit of this atom. So we call this is atom, right? And we call this is nucleus. 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 Okay, so if we have an electron over here and you give photon energy, transfer the energy to this electron, and this electron get energy, and it will from this valence band to another one, but it is still inside the atom. We call this is excitation. Excitation. That means the atom get higher energy. Okay, so this atom from ground state, the atom from ground state to an excited state, excited state. Okay, but what is ionizing radiation? Ionizing means this electron get a lot of energy and it can go outside of the atom. So once this electron go outside the atom, we call this is ionizing. Because after this interaction, we saw a atom, maybe it lost one electron, right? And there is an electron here, so this is an ionizing. OK， 就是电子离开了它的电子轨域，所以它就会留下一个中性不然带正电的离子 ion， positive ion and negative electron emit from this atom or molecule. Okay, so ionizing and excitation is different. Okay, so it depends on this electron gain how much energy and did it has the ability to leave out the atom or not. Okay, so it determines the ionizing. Okay, and it also depends on the binding energy of the electron, right? So if this is a hydrogen, then this electron is easier to be ionized. Okay, so it depends on these two things. One is how much energy you transfer to this electron and how much energy bounded this electron. Okay, and ionizing depends on these two processes. All right, so UV light. This is the wavelength of the UV light, and it did not have the ability to ionize the atom. Okay.
And it has to be a photon.
Again.
It has to be photon, or it could be another part.
Okay, that is a good question. Your question is about how can we get ionizing, right? It depends on the photon or depends on the charged particle, right? No?
No. I mean, if it has to be photon, the element which ionized the particle.
All right. So maybe we can move to this part. Okay. I give you another example. So photon can ionizing the atom is okay, right? Because the photon can interact with the orbit electron. Other ways, if this photon, so what is photon? Photon actually is a light, right? And actually we call it EM wave, right? EM wave, electronic magnetic wave. Okay, so what is the EM wave? It is a large spectrum. So maybe the higher energy is the gamma ray. This is energy. This is gamma ray, and then X-ray, and then maybe if this is the visible light, this is UV, right? This is infrared, right? And maybe microwave, maybe. So for all of the EM wave, we call it light. But when we talk about ionizing radiation, we focus on the energy here because they got enough energy to ionizing the atom. Did I solve your problem? Okay. But another way, not photon can ionizing the materials. Charged particle can do also. So if we have a charged particle like a proton, okay, it got a lot of energy, and it will pass through the material. So if it pass an atom, it's because this Coulomb interaction. So it may ionizing. When it passes through it, it will interact with this material, and this electron might ionizing by this process, by the Coulomb effect. Okay, so we have different way to ionizing the atom. All right. Okay, so for photon and for charged particle, that can ionize the atom or molecules. So we all call it ionizing radiation. All right. Okay, so when we talk about radiological physics, when we talk about it, we just talk about ionizing radiation. Okay, it's a kind of definition. Okay, although our light has large spectrum, but we just focus on this light, this range light, because they just have the ability to ionize, to do the ionizing process. So we call this is the radiological physics. So when you see the term of radiological physics, 就是放射物理的时候，we just talk about the ionizing radiation. Okay, all right. So we didn't discuss the UV and did not discuss the microwave. All right. So all of this can have the interaction that make the ionizing. So for gamma ray is a kind of electromagnetic radiation. So we call it's a kind of EM wave. So X-ray is also an EM wave. So this is the EM wave. EM radiation. Okay, radiation. But it's from different source. It's from different source. Gamma ray from nuclei. X-ray from atom. Does it different? This is from nuclei. X-ray from atom, electron is different, but it's all photon with different energy. So sometimes we will categorize these two kinds of radiation. We say gamma ray from nuclear transformation, okay? But X-ray is from the orbit electron, okay? And the energies are quite similar, not that similar. So for gamma ray from the nuclide is around MeV. No, I'm sorry. Yeah, MeV. And the X-ray cost from the electron orbit change transition is around keV. So you just can get this idea from these terms. All right. And also annihilation radiation, we also call it gamma. It's a little different. So annihilation is talk about electron and positron. They get the annihilation, so it causes 2 photons. We call this 2 photon gamma. Only this one, not from the nuclide. 就是互毁的产生的光子的话呢，它是产生伽马，这是唯一一个不是从原子核里面来的。Okay, and X-ray. How can we get X-ray? It has 2 process. The first one is if we have an electron, this electron has higher energy. When it passes through the nuclide, it will be attracted by this positive charge, right? And the charged particle change its direction, it will emit radiation. And this kind of radiation will be like an EM wave, okay? So we can using this material to this method to cause the microwave, also the X-ray. So the electron approaching the nuclide, and it will change its direction. It is it produces the X-ray, and this X-ray energy we use h nu to express it. This X-ray energy depends on how electron close to the nuclide. So if this electron is a little far away from this nuclide, it might be changed a little bit direction. So this time, this photon will be less energy. Okay? So for this process, we call it Bremsstrahlung. Bremsstrahlung is from Germany, and it means it's breaking, it's stop. Like the electron has kinetic energy, and when I instant to some nuclide, it will be stopped. And this kind of stop, it lost its energy. Okay, so we call it Bremsstrahlung. So this is a way of we cause X-ray. Another way is characteristic X-ray. What is characteristic X-ray? Characteristic X-ray is talk about when you do something, you're ionizing an atom, and here is a vacuum. Okay, and this atom is in an excited because it is not the electron not all fulfilled in their inner orbit. So its outer electron will fulfill into it, and it will emit the X-ray also. And this kind of X-ray has an specific energy. This energy is the difference from these 2 orbits energy level. So we call it characteristic. What is the characteristic? What is the categorized? It's the energy difference of the energy level. Okay? So when we talk about 700, okay, never mind. Okay, so this is an X-ray. And X-ray can be produced by human. So how human to create X-ray? Very easy. We're using an X-ray tube. An X-ray tube. And it has a tungsten over here. Tungsten. Tungsten. Okay, maybe 钨啦哈，它可以用钨。And here. And we accelerate the electron in the vacuum. vacuum tube. Then this electron gain a lot of energy. Then it hit the tungsten. It will produce X-ray in this direction. Okay, this is for KEV process. If this electron were produced with higher energy in MEV, then its X-ray is like this one. Okay, it's the phenomena of the X-ray direction, the branch column direction. If the electron gain energy, then it is incident to a target. If it gets KEV energy, its branch column will go around 90 degrees. But if it gets MEV energy for that electron, then the branch column will go more forward direction. Okay, so we're using these two phenomena. We using this kind of X-ray tube to do a diagnostic X-ray. That is a KEV label. And for this one, we get MEV branch column. So this is an X-ray. We're using this kind of X-ray to do the treatment. So this is in the radiotherapy department. So this kind of radiation, we call it linear. It's using a linear accelerator to accelerate the electron to produce this kind of MEV X-ray. Okay? All right, so never mind. You just need to know about X-ray. We can produce KEV X-ray. Also, we can produce like an MEV X-ray. Okay, but this kind of X-ray could categorize into types. One is branch column. This is the main part of X-ray. And another is characteristic. Once the electron hits the orbit electron, let the vacuum of the atom, then it's possible to produce the characteristic X-ray.
Okay. I would like to clarify if the characteristic X-rays are generated from the K to M shell, the transition from the M shell to the L shell communication. Is it the characteristic?
Yes. Correct. Okay, so this is photon. Any questions? No? Okay, so how about neutron? Neutron is for nuclear reaction. For electron, it's impossible to create neutron interaction. Okay, neutron only interact with the nuclide. Okay, and okay, I don't think this is the correct word. Please omit that. And if we get the neutron from the nuclear transformation, its energy is around MeV. So you just have the idea from the nuclide is around the energy, no matter the neutron, no matter the positron, or no matter the gamma ray, is around MeV level. All right, so what is heavy charged particle? We can go back to charged particle. Charged particle is the particle with charge. Okay, it's easy. And we take out the electron. And this electron can be beta ray, delta ray, or electron. Okay, what difference? Actually, they are the same one. They are electron. But how? But why do we using different name to call it? Do you know why? Could you get some terms of this term? You can recognize what is its definition. Could you tell me what is the source of the beta rays? It's an electron. It's from nucleus. So it's from nucleus. So the nucleus emits, the electron emits from the nucleus, we call it beta. It could be beta, it could be beta minus, it could be beta plus, okay? But it's electron from the nucleus. Okay, and what is the fast electron? If we write down like this one, it outer from the nucleus. It could be the electron in the in the orbit, or it could be electron accelerated by your tube or something like that. So we call it electron. All right, another term. Have you seen this one? Delta ray. 有看过 delta ray 的请举手。Okay, so what does it mean? 来换，你知道什么 delta ray？
能量打到电子，然后电子跑到，就是我们会观察一个水之后区域，然后让电子吸收之后它跑走。
跑到哪里？或者是怎样？那它也是电子啊，为什么不叫它电子？为什么叫它电子？
它本身太高。
那你是原来的作用来，原来那个叫电子，为什么拿出来比较高能量叫电子？ It's much close. Okay, this delta ray is also electron too. But when you have a charged particle or heavy charged particle pass through the material, it will cause ionization. Okay, so I'm using dot to be produce this kind of ionization. So once we cause ionization, then the atom will emit one electron, right? And this electron will gain energy, okay? And this energy, if this electron, ionizing electron, have the ability to, or it get a lot of energy, its ability to go far away from the original charged particle path. We call this electron, we call it delta ray. It's just a symbol or a label. Its original one is electron, but I would like to identify it is in the path or outside the path. Okay, so we call the inside path, we didn't give it another name, but outside the path we give it a name. That is the secondary. Remember, it is a secondary electron. So that is interact, produced that kind of electron. It gets a lot of energy or higher energy. That make this electron have the ability to move away from the primary charged particles path. We call it delta ray. OK， 可以吗？我再讲一遍，用中文讲一遍好。就是我们会分带电粒子，原始的带电粒子，或者是初始，我们就 primary 叫初始。初始的带电粒子进入物体的时候，它就会造成游离，游离的时候就会产生电子。这个电子我们就叫做二次电子，而这个二次电子它就是电子。但是呢，我们想要给一些计量学上面的定义，所以呢，我们要去区分一下，它是在路径中产生的电子，还是有能力跑出这个路径的电子。那有能力跑出这个路径的电子，我们就叫它 delta ray。OK。
Does it only apply to heavy charged particles, or if the gamma ray, it also applies to gamma rays interacting with the electron?
Only for charged particles. Okay. Another question is, how close the range, we call it, I mean, the electron can go how far away, then we call it secondary. Do you know how? What is the close to the path? How to define it? Because we're using this definition to separate in the path, near the path or after the path, right? Okay, it depends on your research. It depends on your research or measurement, radiation measurement or research. Okay, so if you focus on DNA, this would be very close because the energy deposit we call here is energy deposit in the local path. So for DNA, the target, the DNA is very small. So the region will be very small, and the energy greater than this range, we call it delta ray. But if you focus on cells, it's like a millimeter, micrometer. Okay, this is nanometer. Okay, if you focus on cells, then the path will be greater. Or if you focus on the ionizing chamber, it's around millimeter, more bigger. So for these three targets, its delta ray is different. Its definition of its delta ray is different. Okay? Alright, so we stop here and take 10 minutes rest. Please go back at 10:15.